two projects. In this video, we are going to explain about the project title False Positive Identification in Intrusion Detection using XAI. Introduction. In the realm of computer systems, intrusion detection plays a pivotal role as a final defense mechanism. It acts as a safeguard, preventing security policy breaches and unauthorized access attempts, serving as a critical component in maintaining system integrity and safety. Intrusion detection methods fall primarily into two categories: signature-based and anomaly-based. Anomaly-based systems have an advantage in uncovering novel attacks that lack known signatures. However, they tend to generate more false positives, incorrectly identifying benign activities as threats compared to signature-based systems, which rely on predefined patterns. False positives in intrusion detection systems have significant repercussions. They erode the credibility and trust in the system, causing user frustration due to unnecessary alerts or actions. To mitigate these, strategies involving improving accuracy and post-processing techniques like filtering out irrelevant alerts or grouping similar detections are crucial. The proposed approach in the project utilizes explainable artificial intelligence (XAI). This method employs explainable artificial intelligence (XAI) to assess the relevance of various features in the detection process. By combining this knowledge with the algorithm's confidence measure, the system can effectively discern and identify false detections, reducing the occurrence of false positives while maintaining accuracy in identifying genuine threats. Objective of the project: the project's primary goal is to tackle false positives in intrusion detection system (IDS) by leveraging explainable artificial intelligence techniques. These techniques aim to enhance the system's capability to effectively identify and address false detections. The project aims to merge insights gained from XAI, specifically the relevance of certain attributes, with the algorithm's confidence measure. This combination is intended to create a more nuanced distinction between true and false positives within the IDS. By utilizing XAI-derived attributes, the project seeks to streamline the workload of security analysts. This approach aims to reduce the number of instances that analysts need to manually examine for false positives. Ultimately, this not only improves the credibility of detections, but also mitigates potential annoyance to legitimate users by minimizing unnecessary alerts. The ultimate aim of the project is to decrease the occurrence of false positives within IDS. This reduction in false positives contributes to an enhancement in the accuracy and reliability of intrusion detection systems, enhancing their overall effectiveness in identifying genuine threats while reducing the likelihood of misidentifying benign activities. Software and hardware requirements. Hardware requirements of the project are: operating system of Windows, processor of i5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are: application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite3. Front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing the packages. This step involves importing necessary libraries or packages in the chosen programming language like Python. These packages include libraries like Pandas for data manipulation, Seaborn and Matplotlib for visualization, scikit-learn for machine learning algorithms, and potentially others essential for data analysis and modeling. Exploring the dataset. Lycos IDS 2017. This stage involves getting acquainted with the dataset named Lycos IDS 2017. Dataset exploration typically includes tasks like checking the structure of the data, columns, rows, understanding data types, identifying missing values or outliers, and gaining a general overview of the data's characteristics. Data processing. Pandas data frame. This step likely involves converting the dataset into a Pandas data frame for ease of manipulation and analysis within Python. Dropping unwanted column. Here, Irrelevant or redundant columns that do not contribute to the analysis or model building are dropped to streamline the data set and improve computational efficiency. Visualization using Seaborn and Matplotlib. Utilizing Seaborn and Matplotlib libraries, the project aims to visualize the data distribution, relationships between variables, potential correlations, or patterns within the dataset. Visualization like histograms, scatter plots, or heat maps are employed to better understand the data. Label encoding using label encoder. Label encoding is a technique used to convert categorical data into numerical form, allowing machine learning algorithms to process it. The label encoder from scikit-learn is used to transform categorical variables into encoded numerical values. Feature selection. Select percentile using mutual info classify. Select percentile is a method for feature selection that chooses the top features based on a specified scoring function. In this case, it's utilizing mutual information classification, mutual info classify, to assess the relevance of features concerning the target variable. Splitting the data X and Y for machine learning. This step involves splitting the dataset into features X and target variable Y for machine learning purposes. X contains the independent variables used for prediction, while Y represents the dependent variable being predicted or classified. Building the model. This stage involves constructing and training a machine learning model using the processed and selected features. The model is built based on the dataset and its target, aiming to accurately identify false positives in intrusion detection. Techniques like classification algorithm are employed for this task. The model aims to use the chosen features to predict and differentiate between true and false positives in intrusion detection scenarios. Training the model. This step involves feeding the pre-processed dataset into the chosen machine learning algorithm for training. The model learns patterns and relationships within the data to make predictions or classifications related to identifying false positives in intrusion detection. Training involves iteratively adjusting the model's parameters to minimize errors and improve its accuracy in predicting false positives. Flask framework with SQLite for sign up and sign in. Flask is a web framework used to build web applications in Python. Here, Flask is utilized to create functionalities for user sign up and sign in. SQLite is a lightweight relational database management system often used for local development or smaller applications. In this case, it's used to store user authentication details like usernames and encrypted passwords. User gives input has feature values. Users provide input values representing features relevant to intrusion detection. These could be attributes or data points the model uses to make predictions about whether an activity represents a false positive or not. The given input is pre-processed for prediction. Before feeding user provided feature values into the trained model, pre-processing steps similar to those applied to the initial dataset are performed. This ensures consistency and compatibility between the user input and the data the model was trained on. Trained model is used for prediction. The trained machine learning model is employed to predict whether the provided input indicates a false positive or not. The model leverages its learned patterns and relationship to classify the user input based on its understanding of false positives in intrusion detection. Final outcome is displayed through front end. The outcome of the prediction, whether the input represents a potential false positive or not, is showcased to the user through the project's front end. This could be in the form of a user-friendly interface displaying the prediction outcome or relevant information related to the intrusion detection decision. The front end aims to convey the results in an understandable and accessible manner for the user. Algorithms used to implement this project, we have utilized the following algorithms. The first one is random forest. Random forest is an ensemble learning method that constructs multiple decision trees during training and merges the predictions to improve accuracy and reduce overfitting. Each tree in the forest operates independently, making predictions, and the final outcome is determined by combining the predictions from all trees. In this context, random forest is employed as a robust classification technique for identifying false positives in intrusion detection. It's beneficial for handling large data sets, identifying relevant features, and minimizing overfitting, contributing to improved accuracy in detecting false positives. KNN, K nearest neighbor. KNN is a simple instance-based learning algorithm used for both classification and regression. It classifies new instances based on similarity measures, example Euclidean distance, to the k nearest neighbors in the training set. KNN is utilized to predict whether an instance is a false positive or not based on the similarity of its features to the training instances. Decision tree. Decision tree is a tree-like model where each internal node represents a feature. Each branch represents a decision rule, and each leaf node represents an outcome or a class label. It recursively splits the data based on the most significant attribute. Decision trees are interpretable and can be useful for understanding which features contribute most to identifying false positives. Navy Bayes. Navy Bayes is a probabilistic classifier based on Bayes' theorem with an assumption of independence between features. It calculates the probability of a class label given input features using conditional probabilities. Navy Bayes can be effective for its simplicity, speed, and efficiency in handling high-dimensional data. Neural network. Neural networks, specifically artificial neural networks, ANN, consists of interconnected nodes organized in layers, input, hidden, output. They learn complex patterns by adjusting weights through iterations to make predictions. Neural networks, with their ability to capture intricate relationship in data, can be employed for false positive identification and intrusion detection. However, they require more computational resources, tuning, and larger data sets to avoid overfitting. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Comparison graphs. Comparison graphs offer a visual breakdown of how a model performs across essential evaluation metrics. Models are compared with the parameters accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis we have accuracy score and on the y-axis we have algorithm name. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positives and true negatives, to the total number of instances. This is the precision comparison graph. On the x-axis we have precision score and on the y-axis we have algorithm name. Precision is a metric that assesses the accuracy of a positive prediction made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions. True positives plus false positives. This is the recall comparison graph. Here on the x-axis we have recall score and on the y-axis we have algorithm name. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is the FN comparison graph. Here on the x-axis we have FN score and on the y-axis we have algorithm name. FN score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file. which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. So here I'm copying the path. Now open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, this localhost, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are a new user, we need to register first. So click on sign up button here. So here we need to enter all these details to register. But I have already registered. So click on login. So here we need to enter the username and the password which we have created and then click on login. We have logged in successfully. So here we need to enter all these parameters, and after entering the parameters, click on predict button to predict whether attack is detected or not. So here I'm entering the parameters now. So here I have entered all the parameters. So the first one is FWD PKT LEN STD, which is forward packet length standard deviation is 0. It measures the standard deviation of packet lengths in the forward direction. Variations in packet lengths within the forward flow can be indicative of certain network behaviors or anomalies. And the next one is forward packet length mean. It is the value of forward packet length mean is also 0. It represents the average packet length in the forward direction. Provides insight into the typical size of packets within the forward flow, aiding in understanding network traffic characteristics. Forward packet length maximum is 0. It represents the maximum packet length observed in the forward flow. Highlighting the maximum packet size can reveal potential outliers or unusually large packets that might signify abnormal network behavior. Forward segment size average is 0. It refers to the average segment size of packets in the forward direction. Helps in understanding the average size of data segments within the forward flow, contributing to network analysis. Packet length standard deviation is 0. Measures the variability or dispersion of packet lengths in both forward and backward directions. Captures the overall spread of packet lengths across the entire flow, aiding in anomaly detection. Flow inter-arrival time standard deviation is 0. It represents the standard deviation of inter-arrival times between consecutive packets in a flow. Variations in inter-arrival times can signify changes in traffic patterns, potentially indicating suspicious behavior. Backward packet length standard deviation is 0. It is similar to the forward packet length standard deviation, but specifically for packets in the backward direction. Helps in assessing variations in packet lengths within the backward flow. Backward segment size average is 0. It represents the average segment size of packets in the backward direction, similar to the forward segment size average, but focused on packets moving backward in the network flow. Packet size average is 0. It represents the average size of packets considering both forward and backward directions. Offers an overall average packet size for the entire flow, providing a general view of packet sizes. Subflow forward bytes is 0. It indicates the number of bytes in the forward subflow, focuses specifically on the bytes transmitted in the forward direction within a particular subflow of network traffic. These parameters serve as crucial features or attributes used for analysis and modeling in the context of intrusion detection, aiding in identifying patterns, anomalies, or potential false positives within network traffic. After entering all these parameters, click on Predict button. So here we can see we got the result. There is an attack detected and attack type is DDoS. In this way, by entering the parameters, we can predict whether attack is detected or not. And if attack is detected, what type of attack is detected. Now we will enter another set of parameters. So click on Home button here. So here I'm entering another set of parameters now. So here I have entered all the parameters. So the first one is forward packet length standard is 94.36 and forward packet length mean is 42.2. Forward packet length maximum is 211. Forward segment size average is 42.2. Forward packet length standard deviation is 161.40. Flow inter-arrival time standard deviation is 1158. Backward packet length standard deviation is 267.31. Backward segment size average is 154.333. Packet size average is 84.25. Subflow forward bytes is 211. After entering all the parameters, click on Predict button. So here we can see we got the result. There is no attack detected and it is normal. Now click on Sign Out button here. The conclusion of the project is this project's core strategy revolves around leveraging explainable artificial intelligence XAI methodologies. XAI techniques offer transparency and insights into how an intrusion detection system IDS arrives at its decisions. By utilizing XAI, the project seeks to understand why false positives occur within the IDS, aiming to rectify these instances more effectively. The project aims to combine the attribute relevance extracted from XAI methods with the confidence measures generated by the IDS algorithm. This fusion intends to create a more refined decision making process within the IDS, enhancing its ability to differentiate between false detections and legitimate threats with higher accuracy. To delve deeper into the relationship between XAI derived attributes and detection credibility, the project introduces a secondary machine learning algorithm. This additional algorithm investigates how changes or variations in specific attributes impact the credibility of detections. Understanding this relationship helps in fine tuning the IDS decision boundaries. The project's methodology and techniques are evaluated using the Lycos IDS 2017 dataset, a common benchmark dataset in intrusion detection research. This evaluation serves as empirical evidence showcasing the efficacy and practicality of the proposed approach, demonstrating a notable reduction in false positives while maintaining minimal loss in true positives provides substantial validation for the methodology. The overarching objective of the project spans beyond mere false positive reduction. It encompasses a holistic enhancement of intrusion detection systems by reducing false positives, enhancing detection credibility through XAI insights, and minimizing disruptions to legitimate users. The project aims to fortify the accuracy, reliability, and user friendliness of IDS, thereby strengthening overall system security.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.